Okay. Hey, good evening and welcome. Thank you for joining the second talk in this year's Dr. Bruce J. Nelson Distinguished Speaker Series. I'm Hal Van Ryswijk. I'm the John Stauffer Professor of Chemistry and Chair of the department. This year we are extremely excited about our Nelson Speaker Series theme, Maker Cultures, with the goal that we start intentionally creating the culture we want for the new makerspace that will open in the Scott A. McGregor Computer Science Building in spring 2021. We are also eager to explore the question of what is makerspace exactly, and what other forms of it may come what other forms it may come in that defy the traditional description. Each speaker in the series is, in their own unique approach, creating makerspaces or creative projects that they are pursuing. Tonight we are pleased to continue this conversation with Ellen Jorgensen Garnett-Hertz, co-founder and chief science officer at Carverr and founder of the nonprofit Biotech Without Borders. Before Ellen is further introduced, I'd like to acknowledge the generosity of the family of the late Bruce J. Nelson, class of '74, for establishing this educational series to honor Bruce's memory. Bruce died unexpectedly in 1999, though not before having a tremendous impact on the many people whose lives he touched in an unconventional, eclectic, and irrepressible free spirit. He graduated from Harvey Mudd as an independent program of studies major and later earned his master's in computer science from Stanford and his PhD in computer science from Carnegie Mellon. At the time of his death, he was chief science officer at Cisco Systems. We are honored and grateful to the Nelson family for the opportunity we have each fall to host exceptional speakers who are at the forefront of their respective fields. I want to also offer my thanks to my fellow Nelson Series committee members for their work in planning this year's series and bringing Garnet to campus. Faculty members Chris Clark in the engineering department, Fred Lichter of the Rick and Susan Sontag Center for Collaborative Creativity, and our most capable chair, Rachel Mayeri of the Humanities, Social Sciences, and Arts Department. It's my pleasure to welcome Rachel to the podium to introduce Ellen.
Thank you very much, Hal. Hello, art and biology. Good to see you all. I am thrilled to have Ellen here. We got a chance to talk over dinner, and I got to learn about the Harvey Mudd College biomaker space that I didn't realize existed. So this is just the beginning of hopefully a very fruitful conversation to continue onward. It's hard to give a brief introduction to our speaker because she is so productive, but one of the things that I find most exciting about her CV is her interest in increasing science literacy in both student and adult populations, particularly in areas of molecular and synthetic biology. And toward this end, in 2009, she co-founded GenSpace, which was really the first community bio lab in the world, I guess, but it was in Brooklyn. It was named the world's top 10 innovative companies in education. Her background is with a PhD in cell and molecular biology from NYU, and she spent 30 years in biotech. She's honored in many ways as an alumni of the Amsterdam School of Creative Leadership and a member of the G.P. Wright Consortium to construct a human genome. You'll have to explain that. Okay. She recently founded the nonprofit Biotech Without Borders to help provide access to biotech education to all. She has awesome TED Talks, one on biohacking, you can do it too, and what you need to know about CRISPR, and each has had over 1 million views. And then more recently, she's the co-founder and chief science officer at Carverr, which is a biotech startup that safeguards supply chains and promotes sustainable practices by using biomolecules and probiotics to track and trace food and other products. Okay. Without further ado, please welcome Ellen Jorgensen.
Has this mic kicked in? Yeah, yeah. All right, we're okay. So yeah, first I want to thank Harvey Mudd College for bringing me here. And I think it's great that this series was founded in the memory of an irrepressible free spirit, because that's the sort of characters that we have in the community that I've made myself a part of. I think science in general has a lot of irrepressible free spirits, but the DIYbio community is really interesting, and I'm going to tell you a little bit about how we got where we are today in the course of this lecture, and also some of the stuff that is going on right now in the community, and why I think it's really valuable that these spaces exist. So if you ask a scientist, why did you become a scientist? Most of them will say that it had something to do with discovery. And this feeling that you get when you discover something that you didn't know before, and there's this feeling that you're the only one in the world right now that knows the answer to this question. And it's kind of a heady thing. And even if you're just discovering something for yourself that someone else already discovered, but you're doing it for yourself the first time, I mean, that's also a big turn on. And the freedom to look into whatever interests you and to tinker and to invent is something that I think most scientists would say is what got them into science in the first place. And this is something that it's not just scientists that feel this way. If you ask people in the general public, a lot of them have an interest in exploring and tinkering and figuring out how their world works. So the question becomes, who should be allowed to, quote unquote, do science or practice science? Right now we have a system where science is usually practiced in very specific places by people that have had very specific training. And part of what the DIYbio communities did was to sort of push back on that idea and say that there could be citizen scientists that could also contribute to this. I want to start with the three things that really fueled this movement. One is pretty obvious. DNA has become cheaper to both read and to write. The writing is basically a chemical synthesis operation. But the cost of a short piece of DNA, when I was a student, was probably $6,000, and now it's maybe $20,000. So the cost of writing DNA has come down considerably. You can get an average-size bacterial gene for less than $100, and you can get it delivered within a week by mail. This was unheard of when I was a student. The second thing was that when the economic downturn happened in 2008, a lot of startup biotechs went under and their equipment all got dumped on eBay. So you could pick up things like a PCR machine, which is a standard piece of lab equipment, for $100 on eBay. People have gotten wise now. It's much harder to find good equipment for cheap on eBay and auction sites because there's lots of people competing with you. But at the time, it was ridiculously easy to set up a lab for under $5,000. And if you just wanted to analyze things, you could set it up for much less than that. The third factor that I want to go into in a little more detail was synthetic biology. How many of you have heard that term? So most of you, good. Does this school have an iGEM team? No? Okay. At any rate, synthetic biology was an idea that, just in brief, in order to put together useful pieces of DNA, it would be really helpful if the pieces were standardized in some way. So in other words, if you really conform to engineering principles, instead of just calling it genetic engineering, actually put the design, build, test sort of principles into it, such that when you made a construct, if it didn't work, that would be added into the specification of the pieces of the DNA that we're using, and that it would be stored in some database available to everyone the same way that the specifications for, say, a screw or a bolt or an electronics part are in certain repositories of information for everyone to have. And all of this started, what happened? There we go. I think all of this started with some of the leading lights in engineering and computer science saying that the interface of biology and other technologies was the wave of the future. And people started saying, well, if the homebrew computer club could revolutionize the way that computers were built, so going from something like this to eventually being something that you wear on your wrist, what sorts of strides forward could be made in biology if you had sort of a similar underground movement to democratize it and to break out of institutions? So, for example, computer code is essentially ones and zeros, but we have all of these layers on top of it. First, a layer that's sort of like a DOS layer, and now we have all of these wonderful user-friendly interfaces where you don't have to think about the ones and zeros. What if we made biology easier to engineer by getting rid of that complexity? So if this is a gene, instead of thinking of it as a string of A's and T's and G's and C's, you would take each part of the gene and say, well, that yellow arrow, which is actually the color isn't coming out very well in this, but the top yellow is the first part of a gene, something called a promoter. The green part is the ribosome binding site. The long arrow is the open reading frame. And if you think of it in modular terms, and you can express it in a symbolic language, would it be easier to build genetic circuits and to tell other people what you were building? And if you could make these parts easy to fit together, and if you could capture your experience with those parts, whether it was good or bad, say this particular ribosome binding site works great in E. coli but not in some other organism, and put it in a database, then could you move the field forward? Could you make biology easier to engineer? Could someone who came from another discipline, like instead of biology, if they were an engineering student, could they engineer genetic circuits? And so that was the question that a bunch of people set out to answer, mainly Tom Knight and Randy Retberg at MIT. Of course, the chassis that you're putting it into has a mind of its own. It's not like the code that you put into the computer where you have built the computer from the ground up. But be that as it may, a lot of people thought the analogy was worth trying to take it to the nth degree. And so in order to publicize this new field, they started a competition called iGEM, the International Genetically Engineered Machine Competition. And it grew from 8 teams in a classroom at MIT in, I think, 2004, to now it's over 300 teams from like 80 different countries all over the world. And we take over the Heinz Convention Center every year. And that's me. So this is the repository of the information. It's called the Registry of Standard Biological Parts. So this is an attempt to make a database of biology in a way that's user-friendly. Now, one of the unintended consequences of all of this, because this was all within an academic institution, was that a couple of people that had been involved in iGEM, Mackenzie Cowell and Jason Bobe, thought, well, gee, going back to that homebrew computer analogy, if you're telling us that it's safe to work with certain strains of bacteria like E. coli K12, which has been in classrooms for 40 years, if you're telling us that you're going to put information in a database so that we don't necessarily have to be biology majors in order to figure this out and build useful things like a bacteria that eats an oil slick or that degrades plastic or does some, makes a specialty chemical or something. Why can't we do this as a hobby? Could we possibly do this in a safe and productive way? And by the way, it would promote a greater understanding because there's such fear around genetic engineering among certain groups in the United States. You hear things like, well, I would never eat a genetically modified tomato. There's DNA in there, So that sort of thing drives me crazy. And they thought that if you were actually handling this material yourself and you realized what it was, that it would become not this mysterious technology that was being like forced on you it was in your food, it was in your clothing, it was in your medicine, and you had no control over it. Kind of the way I feel about AI. That somehow it would become less scary, it would become more mundane, and the decisions that would be made around it might be better decisions and not just this knee-jerk fear of it. So that was something that motivated them, and they coined the term DIYbio. They started a Google group, and the Google group quickly grew to thousands of members, and very interesting discussions happened on it, but very few people were actually doing anything. A lot of them did not have biology backgrounds, and they were scared of starting a lab. They didn't know what regulations would be involved. They didn't know what sort of pushback they would get. So all of this was pretty much academic until a couple of groups, one in California and the group that I started in New York, started actually seriously trying to figure out what it would take to put together a physical lab space. At the time, the news media thought this was great. There were all of these horror stories about biotech in the basement and what was going to happen, and there was a woman named Kay All who had a lab in her closet, and there was all this lab in the closet. It was like 3 pieces of equipment, and all she was doing was testing herself or something. I mean, it was a very mundane thing, but it got blown into this whole lab in a closet. There was another woman who wrote something called the Biopunk Manifesto and strode around in leather pants, like telling everyone that she had a right to investigate the world through DNA. She also advocated making glowing green yogurt that would test for melamine. That was when the melamine, was it melamine? It was the baby food from China that was contaminated. And so she was going to have this yogurt that would sense, you would mix it with the milk, it would sense this contamination and turn green. Of course, none of these projects ever really came to pass, but they were great for the news media. And so in this atmosphere, and also, thank you very much, Hollywood, for the atmosphere. Have you ever seen a movie where genetic engineering was used for good? I don't think so. It always is kind of part of the evil in the movie. And scientists are usually portrayed as people that are so wrapped up in their science that they don't care what sort of harm they do to society. So faced with these challenges, when we decided to get together and start doing a lab, we realized that it would be really valuable to change that kind of us-them narrative. So we coined the term community lab instead of biohacker space, because biohacker made us sound like we were doing something cool for our own amusement that might be dangerous. Community lab sounded like we wanted to be of service to the community. We decided to incorporate as a nonprofit, which also might give people kind of a friendly feeling about us. And there was some, oversight and hoops that we would have to go through to show that we were operating in a manner that was serving the public. We started out holding meetings in somebody's kitchen. We would put plastic down everywhere. I brought some old lab equipment that I had. And we did very, very simple stuff. We bought a couple of kits that are for high school students, and we went through the exercises. But what this taught me was that the general public was really fascinated with this stuff. Just the idea of using pipetters and seeing DNA actually move in an electrophoresis box, that you could visualize it, was just endlessly amusing to people. And they would gather around it and take all these pictures. And I started thinking that this was really interesting in that when you do science day to day, especially as long as I'd been doing it, you get really jaded to this kind of stuff. And if you're running around chasing grants, or you're doing something in a corporate environment where it has to make money, all of that reason why you became a scientist often gets kind of beat out of you. And I found myself really thinking, yeah, this is kind of cool that there's actually DNA moving from left to right here and that I can actually see it. So in a weird way, the movement started giving back to me like what I thought was cool about being a scientist. Of course, this article, one of our co-founders was a reporter, and without telling me, he wrote this article, which landed on my desk courtesy of my colleagues about a couple weeks after we had done that experiment. And my name was prominently featured in the first sentence. But it was a sign of how this was being picked up by scientific publications, that they cared at all to even publish this. So there was some interest in the professional community at keeping an eye on this movement, but also potentially helping it, because they realized that it could help spread the word about science in general. We moved in 2010 to this very crazy building. That's the owner. This is actually a picture from a New York Times article about him. Virtually every creative in New York City has either worked in this building, done a job for someone in this building, knows someone who works in this building. The owner often let people do stuff in there and not pay rent if it was interesting enough to him. He wanted to have this community of makers in the building. He was kind of the prototype for WeWork in a way, but not commercial. And when we said we were going to go in and put in a biolab, he said, great, make something interesting, which was not the usual landlord response to something like that. So the original lab was quite small. You can see this bunch of people stuffed in. This was actually a group from Google that had some money to spend on a group outing. And it wasn't until the very end that I realized that the woman to my right was wearing Google glasses and was filming everything. So that was my experience with Google glasses. The first classes we started running were introductions to molecular biology, because we realized, we took sort of a poll on that DIYbio group and asked, would you take a class if it was offered? So we were the first that I know of to offer a class in genetic engineering to the general public. And it's popular even to this day. GenSpace is still running this class. And we've taught hundreds of people off the street, basically, to do genetic engineering. The first class that I ran, the reporter who was one of the co-founders said he was bringing a friend of his with a camera, and I was mad and I refused to talk because I was nervous enough at teaching this class for the first time. So the interview ended up being mostly with the reporter, and he made some very funny statements, but it really was a sign of how well we were accepted, that we were simultaneously just about in an issue of Science magazine that was on synthetic biology in this lab of their own article. And at the same time, Nature Medicine did this video of us.
Want to be a molecular biologist? Well, you can be at the world's first community laboratory.
Works a lot like a gym. The idea is that you come whenever you'd like, and you pay dues like you would in a gym.
Using mostly donated equipment and found materials, a small group of biology enthusiasts recently created this lab at a warehouse in Brooklyn, New York.
We built the lab right on this big open space. It's a big glass cube. All the materials that we've made it out of are found materials, so glass doors, windows that were salvaged and repurposed.
22.4 micrometers.
But why would people want to run lab experiments in their spare time?
It is attractive to people who have ideas that aren't necessarily useful, but they're certainly fun.
One of the first projects being developed by the GenSpace team is a device that will be launched by helium balloons 30 kilometers into the Earth's stratosphere in search of remote signs of life.
The High Altitude Microbial Sampling Station, or HAMS for short, is a weather balloon that's going to be lofted up to about 100,000 feet into the stratosphere, capture microbes, hopefully, bring them down in a sterile package, in a sealed package, and then have them analyzed.
So far, the garage biotechnologists have just built a prototype of their microbe catcher, but they hope to launch the real deal later this year. GenSpace is much more than just a laboratory for do-it-yourselfers. It also provides hands-on educational courses for people to come and learn.
It's not just scientists who are working in the lab. It's people who are bringing their own curiosity about the world and bringing it to our lab and exploring.
The GenSpace founders see themselves on the vanguard of a new movement of DIY biology.
So GenSpace is the first community biolab, but it certainly won't be the last. I get the sense that there'll be a lot more labs popping up all over the country and all over the world.
And they think labs like GenSpace could revolutionize the study of biology.
Now that we've reached a certain level of knowledge in the information age, we've come to it's open space for another age, and I think that age will be the biological age. And I think the next great PC computer or Apple computer won't be a computer at all. It'll be this amazing bacteria that has this amazing application that everyone's going to want to have. I don't know what it is yet. If I knew, I wouldn't be talking to you here.
For Nature Medicine, I'm Ailey Dolgan.
The gym analogy has haunted me because it sort of implies a completely hands-off approach to whether or not the person actually knows how to use the equipment. We do require safety training before anybody can use the equipment. But I don't know, it was kind of prophetic in that there are community labs now literally all over the world. This is an idea of the age range of people that use the space. So I think Sid was 13 in this picture, and I don't know how old Larry is, but he's older than I am. He's a retired neurobiologist who had an idea for an RNA therapeutic and was actually pursuing it at GenSpace. Just sort of the hello world of turning a bacteria a different color is enough for a lot of people. We did a lot of classes. We had artists coming in using the space, which was interesting. This was a very interesting project called Stranger Visions by an artist named Heather Dewey Hagborg. And what she did was she collected samples off the streets of New York, cigarette butts, lollipop sticks, chewing gum, and she would extract DNA from them, analyze it for markers of appearance, and make a 3D portrait of someone she'd never met based on their ethnicity, their hair and eye color, and other things that were known about appearance through DNA. And this was pretty crude in 2012, but it was also the year that the Supreme Court decided that it was legal for an arresting officer to take a DNA sample from someone who they had arrested, not convicted, just arresting, and they ruled it was no different than a fingerprint in a breathtaking display of ignorance. So this became a whole project about genomic privacy, and she went on to do a bunch of other projects around genomic privacy and taught at the Art Institute of Chicago and a lot of other things. But she really actually did all the hands-on work herself, which was great. And this was when I realized that art could communicate biology sometimes better than a lecture like this. I mean, I can stand up and say how accessible your DNA sequence is and what people can find out about you. But when you see a piece of chewing gum and then a face, it really hits home that message a lot more, I think, impactfully. So Biotech Without Borders is the space that I run now. This is what it looks like. So this is sort of typical. One of the nice things, Dan mentioned it in that video, is these spaces use found materials a lot of the time to make the lab. I think part of the divide between the general public and labs is the alien environment that you go into when you go into a lab where everything, you might have $20,000 worth of lab benches and this pristine space, whereas if you have non-absorbent surfaces and you work cleanly and you clean up after yourself, if you're just doing what we call biosafety level 1 work, where you're working with organisms that aren't harmful to humans, you can use stainless steel restaurant counters. So that's what we had as lab benches. You don't have to have professional grade stuff. And I think this was particularly important for some of the educators that would come through the space and realize that they didn't have to have access to a perfect lab in order to bring high-level science to their classrooms. We actually put in a small BSL-2 space, so we have a hood where we can work with things like human cells. We teach a lot of classes, and these are just some of the classes that we teach in the space. I've limited the classes to 13 and above just because I found that students below the age of 13 can't really visualize well enough to get a lot out of taking little bits of clear liquid and moving them from one tube to another, which is what most of molecular biology is. We're at a terrible disadvantage at science fairs unless we bring a live animal. We've got the physicists making Van der Graaf generators and the chemists blowing things up, and all we're doing is moving little bits of clear liquid from one tube to the other. I think the idea of informing the public and letting the public get involved hands-on is really critical to the idea of shepherding some of these new technologies. There's this feeling that the people in the white coats are making the decisions. This is particularly true of things like CRISPR. So we teach a workshop on CRISPR where we use yeast and we knock out a gene that is in the adenine biosynthesis pathway, and what happens is a pink intermediate builds up in the cell, and so the cells turn pink, so you can see when you've knocked out the gene. And this is also accompanied by sort of a heavy dose of kind of the social and moral and ethical concerns around this particular technology. If you're not familiar with it, it's basically a word processor for genomes. So you can edit DNA, and last year it was announced that in China the first edited human babies had been born. So there was kind of an international uproar, but now a Russian scientist has voiced his desire to repeat the experiment, so the horse basically has left the barn, and even if we shut the door, this is a reality that certainly your generation is going to have to face. And if you've seen the movie Gattaca, we all know what the negative consequences of that could be. So we held a few of these forum sessions around genetic engineering of humans. These are just sessions where people consider scenarios and questions and get a chance to really think about what they would do if they were placed in a situation. So, for example, if their child had a genetic disorder, whether they thought that the government should pay for edits like sickle cell anemia. You might make 400 visits to an emergency room in your life. Maybe it's cheaper to get a CRISPR-engineered bone marrow transplant. What if insurance companies refuse to pay for the emergency room visits? They're essentially saying you must become genetically engineered. So there are all sorts of questions here that you're going to have to grapple with, which the public isn't even thinking of right now because most people are unaware that this is no longer science fiction. It's become reality. We also invite people to lecture. This is basically on any science or even art science topic. This is a guy who he's created this kind of a feedback device that you can wear that reflects sort of body parameters and emotions. We have people lecturing on just about every subject in science, and we like to keep the lectures free. We have group projects where we try to bring people in around certain kind of easy technique things as sort of a gateway drug to more serious molecular biology stuff. So I love Alaska. I have a cabin there, and so we collected some plant samples, and we're trying to do sort of a survey using what's called DNA barcoding, which is a way of taxonomy based on DNA. And it was an excuse for everybody to get pipettes out and extract DNA from samples. Then we also explored the Gowanus Canal, which is this really polluted, super fun site in New York City. And sort of tongue-in-cheek, in a way, most people are trying to gather precious data on environments that are going to be destroyed by pollution. The canal is slated to be cleaned up. They actually have started cleaning it and sealing it. So this was an opportunity to gather data from a toxic environment before it was remediated. The hope was that we would find some bacteria that were happy living on all of this toxic waste and potentially could be useful in detoxifying sites. And this was one of our first academic collaborations. We collaborated with a metagenomics group at Cornell and actually got our organization listed on a scientific paper. And some of the people were in the arts on this project, so data visualization. And this was a postdoc from that Cornell lab working with a couple of designers to create this really cool interactive map where if you hovered over the site, it would tell you not only which bacteria were there, but in sort of what proportions. We also wanted to make ourselves available to the many colleges and high schools in New York City, most of whom don't have even the most basic equipment. So we ran summer internships just about every year when I was there, and in Biotech Without Borders, we're continuing that tradition. We also have iGEM teams. I've run an iGEM team just about every year since 2011, and this was our first one. And so that genetic engineering competition that I mentioned, we're involved in that, which is pretty brutal. Actually, if you know anything about it, there are all of these deadlines that are terrifying, like you're supposed to put all your data on this website, and there's a wiki freeze day where they freeze the website, and if you don't have all your data on it, then basically it didn't happen. So we're dealing with that. The wiki freeze is in about 5 days, so I have panicked people back there. And we actually did win some awards, which is kind of cool. We also are valuable to New York City teachers. There are a lot of high school teachers, particularly through a program called Math for America, which supports math and science teachers in the city. And we run this Hack the Helix program where they can come and try out some of these classroom exercises like the one around the bitter taste gene in an environment where they're supported rather than just buying this kit and you pay $200 and if it doesn't work you've wasted $200, because it's never as easy as it says on the box with the kit. So it's nice for them to come in, and then we also give them alternatives to not buying the kit, because we buy stuff in bulk, so we can either get a lot of stuff for free or give it away. Then, of course, we go to science fairs once in a while. This is a bacterial painting group where they're using different bacteria to paint little pictures on Petri dishes, and we take them back to the lab and develop them and then send them photographs of their little paintings. And we've done workshops as far out as this is Maker Faire Africa in Cairo. So these spaces can really make a huge impact, even though they're small. I mean, GenSpace was basically being run by half a dozen people, and we did all of this stuff. So it was pretty cool. And then the last component that I really like is this entrepreneurial component, because a lot of people find themselves in a situation where they don't have an academic lab where they can try out their invention or whatever, or do a proof of concept. And so these are 3 different entrepreneurs that were in our space when I was running GenSpace. The one on the left, Erica, she was a former process chemist at Merck, and she had this idea of replacing some of the toxic ingredients in personal care products with some sort of protein formulations that she was building. And she just needed a place where she could do stability studies. The one in the middle was a guy who was at I think he was in that Bioentrepreneurship program at NYU, and he entered a business plan competition around turning the spent waste from the brewing industry into animal feed by converting it to sugars with some sort of bacteria or fungus, I can't remember. And all he wanted to do was do a proof of concept to see if it was economically feasible, basically, if you could do it and have it cost less than regular feed sources. And he actually found that at least at the current time it wasn't. But it allowed him to actually do the hands-on work to figure that out, which was great. And then the third is a guy who started his own biotech company and does sort of fee-for-service biotech out of these labs. So you do get people, and we've had people come in that have had microscopy techniques. There's a group from UPenn that came this past summer to my lab and used the lab to try out this nano injection of DNA into cells thing that they had pioneered. So the fact that we're charging them $100 a month to be members of the space, and they don't have to pay, the lowest cost for a biotech incubator space is about $1,000 a month. And you don't get very much equipment. You get a few pieces of core equipment. But we provide everything. This is a guy that actually some of us were talking about at dinner. This is Will Canine, and that is the first prototype of the Opentrons robot, which he made as an assignment in a class he was taking at NYU. And he was using a lot of 3D printers, and he took a class with me at GenSpace and said, pipetting is really boring. Can we automate it? And he didn't know that there were professional robots. But he hit this sweet spot because the professional robots are usually these monstrous things that cost $100,000, $200,000. And he built one. His prototype cost him about $2,000. And he ended up founding a company called Opentrons. And now the Opentrons robot that sells for $4,000, they went from a successful Kickstarter to an accelerator program called Hackcelerate that sent them to Shenzhen to redesign the robot for mass manufacture. Then they became a Y Combinator company, and now they have offices in New York and Shenzhen. And this is all from this crappy little robot that he built at GenSpace, and that picture of him was at Maker Faire, New York, showing it off. So things that come out of these spaces can actually become commercial products. This is the DIY from the DIYbio website. This is people that are self-identifying as doing DIYbio, so I don't know how accurate it is. There are more labs than are on this. I'm sure there's some in China. I know that there are some that are not on here. There's some in Africa now. It can be really easy to start one of these labs. A lot of labs started by raising money on Kickstarter. So this is one in Northern California in the Berkeley area called Counterculture Lab. And this is what it looks like today. Someone was asking me about Keone. That guy on the left is Keone. And the guy on the right is a guy named Patrick, who is instrumental in starting not only this lab, but also BioCurious, which is the other big lab in California. And this is typical. You can see this jumble of stuff because a lot of these makerspaces get a lot of donations of things, and sometimes they're useful and sometimes they're not so useful, but you never throw anything out because someone else might find it useful. So you end up with a lot of kind of, not exactly junk, but a lot of lab stuff that may not be something that you need right at the moment, but you don't want to throw it away because someone might want it for a project. These are some of the logos of some of the hacker spaces around the country that are doing biology. Most are on the east or west coast, but there are some in the middle of the country, and there are more growing every day. I think for the first few years that I ran GenSpace, every month I got a call from someone wanting advice on how to start one of these spaces. This is the Community Biolab Summit, which is something that MIT started running in 2017. And that was the first cohort, and now I think it's probably at least twice as big. It was just actually this past weekend was the latest Bio Summit. And they're promoting it quite heavily. And because they give out scholarships for people to fly to the summit from other countries, they're promoting a really free exchange of information and best practices, which is kind of cool. These are some of the projects that happen in these labs. This is the Real Vegan Cheese project, which I think started out as an iGEM project when community biolabs were allowed into iGEM, where they were going to replace the casein protein from milk. They were going to make it in a yeast, and so it would be vegan, but you would be able to make something that really tasted like cheese out of it. This idea has now become a huge moneymaker in the synthetic biology business. There are several companies that are the darlings of Wall Street that are based on similar practices. If you've heard of something called the Impossible Burger, the Impossible Burger is flavored with a plant hemoglobin that originally, I believe, it was produced in genetically engineered yeast. I think they may have backed off from that, and they may be actually extracting it from plants now because they didn't want to say that they were using GMO ingredients. But the flavoring industry, and particularly mimicking things that are not animal, that are animal-based with not animal-based things, is a huge business now. Kombucha Genomics is another California project. They're just for fun trying to see what all the different strains of Gluconacidobacter and yeast are that make up the drink called kombucha, which a lot of people are addicted to, including me. It's really fascinating because you can get these microbial analyses now through kits because people are analyzing their own microbiomes, and instead you can send in a sample of this. And actually, if you all know the story of a company called DIYbio, it was one of the biggest ones. It was in Northern California, and they recently got shut down by the FBI, not for anything they were doing scientifically, but someone in the billing department they were double billing for people were getting their microbiome done and getting it through a doctor, and they were billing their insurance, and somehow someone was double billing. And so they got shut down for business practices. But they would send these kombucha samples into DIYbio, and I always wondered how they got incorporated to the database that DIYbio was running, because when you got your results back, it would show you where you were compared to everyone else whose biome had analyzed. So it must have been really strange. And when the company was really on its last legs, it's now filed for Chapter 11, they sent in a couple of samples, and what they got back was obviously some person's microbiome data, so they had mixed up the samples. So somebody got back their microbiome data that basically they were kombucha. So that must have been really interesting. But this is kind of the era we live in. We live in an era where you can query things that you never were able to have access to before because the technology has become more accessible. So Citizen Salmon is a project on salmon genetics that's being run by, I believe, Sound Bio, which I think is in either Portland or Seattle. This was a very controversial project that got kicked out of BioCurious, where they were trying to make a plant that glowed in the dark. And this was the first demonstration that a consumer product around genetic engineering was something that the public would like, as long as it wasn't food. So they put this on Kickstarter, and their original goal was $60,000 to pay the people that were actually doing the work and also to pay for the DNA. We were at a conference together when this was happening, me and Patrick and a bunch of other DIYbio people, and we watched the Kickstarter go from 60,000 to 100,000 to 200,000 to 300,000, and by the time it stopped, they'd raised $500,000. And then suddenly someone realized that there were 7,000 people who now had bought the reward of these GMO seeds they were going to make, and that they could do whatever they wanted with them. They could throw them outside a car window. They could, And so there was a massive campaign launched against Kickstarter called Kickstopper by the Friends of the Earth. And Kickstarter backed down, and now you can no longer offer genetically modified rewards on Kickstarter. This is another project that is fueled by all of the outrage of drug prices. It's called the Open Insulin Project, and this is also going on in California. The idea was that if you could make a more generic form of insulin that was cheaper, that it would benefit everyone. So they went to try and develop a different synthesis pathway that wasn't patented, which I'm not entirely clear about. They originally said that they were going to try and patent it, but give the license out to anyone who wanted to do it and sort of do it as a generic and challenge the drug companies. I heard recently that some of the people involved in the project are also concerned with apocalyptic scenarios, like what if, the end comes and I'm diabetic and I can't get insulin. So there is a component of DIY in there. It's going to be interesting to see how this gets handled by FDA. So if you make your own medicine and you administer it to yourself, are you violating any sort of FDA standards? The FDA really was formed to prevent people from marketing quack medicines. So the marketing portion is what they really are controlling, whether or not you can sell it. But if you're not selling it, what happens then? This is being pushed totally to the envelope by a guy named Josiah Zahner, who started a company called Odin, where he claimed he was democratizing biotech, but he's really making a lot of money selling these kits. And some of them we've tried, and they don't work all that well, but he's become quite the character on YouTube, particularly with that genome editing system called CRISPR. He got up at a scientific conference and said something to the effect of, well, everyone is debating as to whether or not people should be allowed to treat themselves. Well, too late, and injected himself on stage with what he said was a CRISPR-containing plasmid. He also has YouTube videos of himself trying to strip the top layers of skin off his arm and rubbing a CRISPR plasmid into his skin to try and transform his arm with a gene that makes your muscles grow big. Recently there was a complaint filed in the state of California for practicing medicine without a license, which he seems to have successfully dodged. But this is the sort of thing that it kind of brings the tension, the major tension in the community to the fore, which is how do you make something completely accessible? How do you promote innovation and yet maintain standards of safety and common sense when people often can't be trusted to police themselves entirely? We've done a pretty good job in the community with just peer pressure and the feeling that if you make a mistake that you're going to shut down all the labs and all your friends are going to be mad at you. But then you do get people who persist for their own personal gain in spite of that. So I don't know how all of this is going to fall out. I know that there's been an effort to potentially make some rules and regulations, whether they be self-imposed or imposed by the government. The guy who was talking in that video, Dan, partnered with a biosecurity expert that he met at the Wilson Policy Center to get this huge grant from Open Philanthropy to see what sorts of biosafety and biosecurity measures would be appropriate for this community. So I think the handwriting is on the wall that the practice has become widespread enough and we've gotten enough publicity that we will essentially get at some point regulated. And I'm sorry to see that happen, but at the same time, I think it's kind of inevitable. So just to recap what these things are good for, I think it's important that they be nonprofits because that shows commitment to the community, and it also shows a commitment to the welfare of the people that use the space over the profit of the space. I like the idea of labs being open to the public because I've met so many people that couldn't follow their dream one way or the other unless they had access to one of these. And just the sheer variety of people, from students to the intellectually curious to entrepreneurs to teachers to, all different people use these artists who use these spaces. It's really kind of cool. Also, it's important that some sort of mentoring and safety training be provided either on a volunteer basis or by paid staff. Fostering science literacy to me is the main component. I always say that if you've done genetic engineering side by side with your teenage daughter in our space, you're much less inclined to get hysterical about it. Most people don't understand that their kids are doing it in AP biology. It's not some weird, strange, esoteric practice that that can go horribly wrong and create zombies. And also, it's important to keep the talks and workshops low cost or free, and to really promote informal science education in form of things like peer-to-peer learning, or scientists just dedicating their time and interacting with the general public, and learning how to communicate a little better with the public. So that's really all I have to say about these spaces, and I hope that I heard that you guys are about to open your own makerspace on campus, that you do have a small space. Is there going to be space for the biology in the new building that's being built? I would definitely suggest it, because I think that biomaker spaces they're slow to take off, in that the value of what you make in one of these spaces isn't something that you normally can take home and show to your friends. It's not like I made a digital alarm clock, or an automatic pet waterer with an Arduino or something. It's more like you may have, I don't know, engineered a bacteria to eat plastic, or maybe it spits out a perfume, or something a little more esoteric. But I think that biomaking is definitely a wave of the future, and certainly biomanufacturing. A lot of manufacturing practices are now thinking about going greener, and one of the ways to do that is to involve biology in making things, rather than, say, extracting sandalwood fragrance by cutting down a bunch of trees. If you can engineer yeast to make it, and then just take it out of that vat, you can have more sustainable practices and also greener chemical production. So anyway, that's it. Any questions, or? Anyone have any questions about these labs? Yeah. I know that there is some effort I believe, in Europe around that. I know that someone was trying to extract hormones from urine and recycle them. We were approached to see whether or not we could make a strain of yeast that would detect sort of hormone pollution in waterways. But when I looked at it, it was too complicated, because estrogen was not one chemical. It was a whole suite of chemicals, and it would involve having a standardized curve and stuff to be able to tell whether something was over the limit. And it wasn't anything that could be done in a home kit easily. So, but yeah, there is a great deal of interest in that. Anytime, though, you're making anything you're going to administer to yourself, most of the cost is in the quality control. You've got to understand that if you make something in a fermentation of some sort, you have to get rid of everything except the chemical that you want to inject into yourself. Some of these bacterial factories have compounds in them that would be toxic if you injected them into yourself. So you have to make sure that you've purified whatever it is away from anything that might be a contaminant. Yeah. There used to be a group called LA Biohackers, but I'm not sure if they exist anymore. There's something called The Lab, which mainly is advertising to, I think, people who want to invent stuff and start biotech companies, but they may have a component. I know that the people that started originally were saying, well, we're going to finance the hobbyists by charging people that want to do companies a higher rate. So I don't know if the lab takes just the intellectually curious or not. Certainly the makerspace here is already open, as far as I can tell. At Harvey Mudd, there is a group that has an open space, right? Yeah. I think this needs to be publicized a little bit more.
So one of the things that was really exciting to me is like I had always been thinking of this makerspace of what's it going to do for us, or what capabilities do we want, but you created these as sort of an outreach to the community, and so how would we begin to think about not just a room in the basement of the building that perhaps some of us know about to something that's a real resource to our wider community? Who designed that in from the beginning of what you did?
Yeah, and part of it was self-defense, like I said. We wanted to make sure that we were viewed as an asset rather than a liability. But I'd say one of the easiest places is high school teachers that are teaching AP biology. And if you can give them stuff that adds value to what they're doing, I mean, even to have students who are biology majors come to their classrooms and either help with a workshop or talk about their career paths or anything, and just start that kind of thing. I mean, the other thing is you must have some sort of science fair type things. I mean, we used to go to Maker Faire. We used to go to the New York Science and Engineering. I'm sorry, the what is it called? The World Science Festival. The U.S. In Washington, there was a big science and engineering fair we would go to. So participating in those, I mean, those are fun. I mean, most universities have some sort of outreach where they do things for kids. But I think it's really satisfying to do things for older students, too, if you can. I hate to say it, but that ag or art thing is really a winner for engagement. The American Society for Microbiology actually has an ag or art competition now that you can join in, and I think they will actually send you the strains or tell you where to get them, and then they have a competition to see who can, you know, people recreate Van Gogh's Starry Night on a Petri plate and stuff like that. And then, you know, the whole idea of finding something out about yourself. So when the horse meat scandal hit Europe, people went to DIYbio spaces because you can do DNA barcoding and find out whether you've got horse meat in your meatballs or not. So the idea that you can directly query your world through DNA that you weren't able to access before. I've seen activities around groups of students who their culture didn't want to eat pork, so they would bring in foods and test them to see whether or not they were really pork-free. You can test for invasive species. You can, I mean, you can do a lot just by testing, not by building. So if all you have is a PCR machine and a gel box and the ability to send things out for sequencing, you can do quite a lot of different activities that are engaging to the public because they're finding something out. We used to do an ancestry exercise in the classes. So that's kind of fun. We have an open night, like once a month, called PCR and Pizza. And we test for the CCR5 gene, which is, there's a deletion in this one gene that's the main point of entry for the AIDS virus. And if you've got double deletions in CCR5, you're much, much less likely to get sick from AIDS. Not that we advocate going out and sharing needles after that, but it is an interesting story because it was something that was relatively unknown until an AIDS patient got a bone marrow transplant and their symptoms started to resolve, and they finally tracked it down to the guy who was a bone marrow match and a rare double deletion mutant in CCR5. So, and it's something you can see on a gel, so you can get the answer right after you do the PCR. So I would also advocate group projects of some sort. there's several you can tap right into. That kombucha genomics project is one. Another is there's something called the Open Plant, where there's a group, I think it's actually based in the United Kingdom, but they're trying to use this easily transformable liverwort, which you can culture in petri dishes, as a model genetic engineering thing for plants. And so they're trying to make different parts, DNA parts for the plants, and they're trying to get all labs involved in it. So you learn plant tissue culture and stuff like that. And use the professors that are in this area too. You know, get someone to come in and teach a workshop in something. That's always fun. Yeah. Mm-hmm. Well, I think that the whole synthetic biology movement has been very clever this time around, because most of them are avoiding biomedical. And we're actually in kind of, there's a whole advocacy movement in New York City, because we're all mad because the governor of the state of New York and the mayor of New York City got into a kind of pissing contest over who could throw more money at biotech. And so there's like 500 million from the state and 500 million from the city. They're supposed to be devoted to biotech, but they keep thinking medical, medical, medical. And we have all of these great companies now in the area that are doing things like Modern Meadow, that's making synthetic leather out of genetically engineered collagen. We have just other companies that are doing cool things with biology that are more based on new materials or new processes, flavors and fragrances, things that don't, you know, there's the whole spider silk thing where you've got this company called Bolt Threads that's making spider silk ties. It's other areas besides medicine, and I think that's where some of the, and the, you know, the foods area too, that's where kind of the VC money is going. They are still suspicious of the biotech because that goes biomedical because of what you said, but they're much more willing to invest in companies like the one that I've started, which is this track and trace thing, which is avoiding a whole bunch of regulations because we're not, it's not functional in a way that involves human health. And by the way, California, people are much more willing to invest. New York is catching up, but very slowly. The investors on the East Coast are much more conservative. There's so many people in California that made so much money over, like, I don't know, companies that make gifts or something, that they're throwing it around to see, hedging their bets and funding a lot of small startups, because to them, to throw, you know, $500,000 into a startup is a drop in the bucket. So look at the VCs in California if you're going to start something. And by the way, another thing that I think is a really good sign is if you have a scientist and a non-scientist that are collaborating. Because the non-scientist often has the vision that's outside of the box, and the scientist is the one that brings them down to earth and says, well, this is the way we can actually do it. So you asked me what would be kind of a successful recipe. Any other questions? Yeah. I mean, there are a lot of Chinese products that are cheaper that you can go on Alibaba and order. It takes longer to get them, and sometimes they aren't as high quality. I think that's where Josiah is getting some of his things. I bought some pipetters from him when he first started, and I was trying to support him. The name, the Odin, rubbed off like the first week. I mean, and you know, I'm very suspicious on the calibration of those instruments. But if you're just doing it from the perspective of educational, then that stuff is fine. I get a lot of stuff from companies like the mini PCR people and Carolina Biological, because they try to keep the prices low for academics. You can still get some stuff on eBay. I'm not saying you can't. You just have to look a lot harder. The other thing is that there are auction houses that will buy an entire lot of stuff. And if you just look at auction, like Google auction for used lab equipment, you'll often find warehouses. But you have to pick everything up, and it's just completely non-guaranteed. So sometimes you get something that works, and sometimes you get something that's a lemon. I have a PCR machine that I literally have to pray to every time I turn it on, because half the time when I turn it on, the software just gives me that blank screen of death. So I sort of get on top of it and go, please, please, please work this time. But, you know, it was a $4,000 machine, and I think I got it for $300. So. And then the last, I was telling somebody here at lunch, there's some repository here in the state of California that's only accessible to people in California, where it's companies that are jettisoning used equipment and they're giving it away. So I don't know who they give it to, whether it's only to legal entities or whether people can just ask them for it, and I don't know the name. But, you know, if someone wants to email me and remind me, I'll ask the other DIY spaces in California, because they've gotten equipment from them. Depends on what you're testing. See, the thing is that, you know, every time you test for something different, a lot of times you need a different piece of equipment. So every time you work with a different organism, you need a different piece of equipment. So that's what drives the cost up. It's not like all I need is a 3D printer and a laser cutter. It's like, oh, if I'm going to do plants, I need a plant incubator. If I'm going to do bacteria, I need a bacterial incubator. If I'm going to work with yeast, I need this, you know, and it starts fungus, you know, it's something else. But if you just want to test DNA, if you're just talking like DNA barcoding and stuff, then that's really simple. You just need a PCR machine, a gel electrophoresis rig, and a light box to read it, some pipetters, and a centrifuge, and that's pretty much it. A microwave. I mean, we're probably talking less than $2,000. Good luck.
So let's thank Ellen again for joining us this evening and sharing about her work.
Thank you.
And I hope to see you on Thursday, November 14th, when the next lecture in the series will be presented by D.K. Oseo Asare. Thank you and good evening.